This is section 7.2, part B, ellipses and circles. Eccentricity is the ratio C to A of an ellipse. This value will always be between 0 and 1 and will determine how circular or how stretched out the ellipse will be. Now remember, if we're in either form, the A squared is the larger value and the B is the smaller value. To find your C squared is equal to A squared minus B squared. But our equation for eccentricity is E is equal to C over A. The value C represents the distance between one of the foci and the center of the ellipse. As the foci are moved closer together, C and E both approach 0. When the eccentricity reaches 0, the ellipse is a circle, and then the closer it gets to 1, the more stretched out it will be. So we need to determine the eccentricity. So the first thing we need to do is identify our A and our B. Right now, our A squared is equal to 100. Our B squared is equal to 9. When we get our A by itself, A is going to equal 10, and B is going to equal 3. But we need to find our C value. Remember, C squared is equal to A squared minus B squared, or 100 minus 9. So C squared is equal to 91. When you go to find your eccentricity, it's just C over A. Our C value is going to be the square root of 91. Our A value is 10. And if we divide this out, we're going to get an eccentricity of 0.95. which means this is going to be a pretty stretched out ellipse. It's not going to look very circular, it's going to be very stretched out. The shape of an eye can be modeled by a prolate, which is a three-dimensional ellipse. The eccentricity of a center cross-section of an eye with normal vision is about 0.28. If a normal eye is about 25 millimeters deep, what is the approximate height of the eye? So if we cut the cross section, we're going to end up with an ellipse. They tell us that it is 25 millimeters deep. Because it's going to have a center, we can find the halfway mark, and each of these will be 12.5. Now this is the wider part of our ellipse, so we know this is our A value. The whole width is equal to 2A. So we do know that our A value is the distance from the center out to the side of the ellipse, or A is 12.5. Now we know our eccentricity, in this case, is 0.28, and we know eccentricity is equal to C over A. So 0.28 is equal to C over 12.5. We need to get the C value by itself. Right now it's C divided by 12.5, so we are going to multiply on both sides by 12.5. And we will end up with that C is equal to 3.5. Now once we know our C value, we can solve for B. Remember, C squared is equal to A squared minus B squared, or 3.5 squared is equal to 12.5 squared minus B squared. If we square and then we take the 12.5 to the other side, we're going to end up with negative 144 is equal to negative B squared, or 144 is equal to B squared. If we take the square root of both sides, we will get that B is equal to 12. Since we know that B is equal to 12, we can put this on our ellipse. The center out to the shorter part of your ellipse will be 12 on both sides. So the whole height of the eyeball will be 24 millimeters. The standard form of an equation for a circle that has its center at h and k and a radius of r is x minus h squared plus y minus k squared is equal to r squared. Now we need to write an equation in the standard form, and we're going to identify which type of conic that we're looking at. So this could be a parabola, an ellipse, or a circle. Since we only have one value that is squared, this is most likely going to end up being a parabola. We're going to take everything that has the square value on one side, everything else on the other. Since the x is squared, we'll keep the x's on the left, move everything else to the right. Now, we are going to need this to be a perfect square trinomial on the left side, so we are going to have to complete the square. Remember, we do b over 2 squared. Our b value is -6. -6 divided by 2 gives me -3, and -3 squared is 9. So we're going to add a 9 and subtract a 9, or put a positive and -9. We're going to take that -9 to the other side. And then on the left, we will have our perfect square. Since we have a -3 in our parentheses over here, this will be an x minus 3. And then when we take that -9 to the other side, we're going to end up with 2y plus 4, because -5 plus 9 gives us a positive 4. Now, to be in the correct form of a parabola, we do need to have that p value on the outside, because it's 4 times p. So the y needs to be by itself. If we factor out a 2, 2y divided by 2 is just y. 4 divided by 2 gives us 2. So this is our equation, and this is a parabola. If we look in this case, we do have an x squared and a y squared. So this is either going to be a circle or an ellipse. If there are no values in front of x and the x squared and the y squared, or if the values in front of x squared or y squared are the same, it will be a circle. If there are numbers out in front of x squared and y squared and they're not the same, then it will be an ellipse. So since this is x squared and y squared with no values, this one will be a circle when we're done. So we're going to group the x's together, group the y's together, take the constant to the other side. We are going to have to complete the square for your x and your y. The b value for your x's is a -12. So we're going to add a positive and -36. The b value for your y is positive 10. So we will add a positive and -25. Now we can take the negative values to the other side of the equation, and then we will do our perfect square trinomials on the left side. Because we have a -6 in our parentheses up there, what multiplies to get 36 adds to get -12. It's going to give us -6, and it's going to be squared. What multiplies to get 25, that adds to get 10, will be a positive 5. And when we take those to the other side, we will end up with 49. And this is in the square. This is the standard form of a circle. If there would have been values in front of those parentheses, we would have needed to divide what our answer was on the right side to make it equal to 1 to make it an ellipse. Let's look at one more of these. Now we do have an x squared and a y squared, so it's either going to be a circle or an ellipse for this case. Because there is a 4 in front of that y squared, we do know it will be an ellipse. Again, we're going to group the x's and the y's and take the constant to the other side. Now because the y is just a y squared and it doesn't have just a y with it, we are not going to have to complete the square on that one. We will just factor out the 4. But we do need to complete the square with the x's. Our b value is -6. So we're going to put a positive and negative 9. We're going to take that negative 9 to the other side, and we can write down our perfect square. So this is going to be x minus 3 squared, because negative 3 times negative 3 gives me a positive 9. Negative 3 plus negative 3 gives me negative 6. If we take that negative 9 to the other side, 7 plus 9 is going to give us 16. Now we do need to factor out that 4 because the y needs to be by itself. And so this is going to give us x minus 3 squared plus 4 times y squared is equal to 16. Because there's a value in front of that y squared, we are going to divide because this is not in the shape of a circle. So we'll divide everything by 16. So our equation is going to be x minus 3 squared over 16 plus y squared over 4 is equal to 1. And so this will be an ellipse. If you wanted to write this y differently, you could write it as y minus 0 squared, so it's easier to identify the center, but those two are interchangeable.